All right, so this is about the easiest way to understand the singularity. Okay, imagine the waters of space. Now watch this explosion here. You see that flash, that real quick flash? Even at hundreds of, I think 120,000 frames per second, that flash was still very fast. You see what I'm saying? And that right there laid out the proto-light for the universe. That's like a field of neutrinos scattered all across the universe. Okay, the first light. And this is where asymmetry comes in. Now, every time we try to split them, we always get an asymmetry product instead of a symmetry. We think there'd be a symmetry, okay? Well, the problem is when these neutrinos are into place, when we try to split them, we're going to get an antiparticle because once it's geared, it's like it knows that there's a universe into place. You know, it knows that there's a light field of neutrinos, okay? It knows that there's a fabric there. And every time we try to break them apart, instead of getting a symmetry, we get an asymmetry. We get an antiparticle, okay? And that's because they're interacting with the proto-light that's scattered. The neutron, basically a neutral field. It's like a neutral field. But it's a light field. It's the proto-light. It's the ether, more or less. Let's watch it again. See that flash? Boom. And then imagine that universe expanding out. You see what I'm saying? And it goes into and turns into a galactic nebula. Let's watch it one more time. Now imagine you are space. And that was the Big Bang. And those are billions of years. Now watch. And then it collapsed. See that proto-light? Alright. Imagine you go to sleep, alright? And then you wake up 8 hours later. You're technically millions of miles, hundreds of thousands of miles at least away from where you were when you went to bed. Now you might be in your home, in your room, in your own bed. You haven't even moved. But technically our planet and our galaxy and everything has moved through space. So technically space moves through us. Like right now, space is moving through us. Technically. Because of this proto-light. This is a neutrino. It's the neutrino static of space. It's like a neutral static. Imagine a TV screen. This is why particles are quantumly entangled. Alright, now see. Imagine the light, that proto-light is the layout, the screen, okay? And the neutrinos are the static and the particles in it, alright? Now they're bound together by the screen, okay? Where you have a particle here, you have a particle here. You can see they're everywhere. Okay, but they're quantumly entangled by that light because that light is the layout. It's the screen. Okay, so that proto-light is what quantumly entangles particles together. They're bound by the screen. All right, so here's a repeating pattern. Okay, at first, on the quantum scale, pre-singularity, point particles, micronova, popped in. So you got nuclear popping. Okay. And when we look up into space, we see supernova, nuclear popping, all over the place, like you know, Christmas lights popping or flashing. The Big Bang did the same thing, but there has to be. I mean, this is just the theory here, but I mean, it makes perfect sense because our universe is finite. You see what I'm saying? It has only so much energy in it, but space itself has infinite energy in it. Okay, so that means there has to be infinite, finite energy sources. You see what I'm saying? If there's infinite energy in space, but these universes are only finite, then there has to be an infinite amount of finite universes. You see what I'm saying? So multiverses is technically corroborated through the laws of probability. I'm just throwing it out there. I mean, logical laws of probability and science indicate to us that multiple universes literally have to exist. They have to. Now, I'm just throwing this out here. Our DNA, it's limited. It only has 3 billion base pairs, or 6 billion digits. Okay? So, that means that it has a beginning and an end. That means it's a finite code. That literally means that in the universe, or the multiverse, at some point, that DNA code will have to repeat. The laws of probability indicate that that code will have to repeat because it's finite in an infinite, vast, fathomless existence of infiniteness. I mean, that's the only way I can put it. You know, can't stress that enough. You got to understand that it just never ends. You know, it's existence. It's an area that just goes on forever. You know, the plane of existence. So anything finite inside something infinite, there has to be many of. Just through observing the laws of nature and physics. So since this nuclear alpha is carbon base, okay, it's ash base. So when it forms a neutron star, it's like a giant diamond in the sky. The quark gluon plasma is essentially a giant diamond. Okay, it's the hardest element there is. And it's analogous to the phoenix rising from the ashes. So when this starts heating up and it goes through this process, I call this a reverse triple alpha process. Because what happens is this carbon will break down. Okay? Instead of like how stars will add particles together to make other elements, this will break down what's already an existing element. You know, the ash, the carbon. So it breaks it down into three constituents. Primary constituents, hydrogen, helium, and lithium. But it doesn't break them off necessarily in this. They only form after the singularity dies. You know, it breaks them down in this process and then expels it. And then that's when hydrogen, helium, and lithium form. Because that's the basis for everything that starts to form. And then whenever Earth forms, carbon and nitrogen, 6 and 7, form organic compounds which pretty much evolve life. But you have a unified field on Earth also. See, electromagnetism does not form until you have electron uniformity. Prior to that, it's only electrostatic. See, if you have, say, an electron here, electron here, electron here, electron here, no, okay? What can you do with that? Well, you really can't do anything with it because it's static. Now, you might be able to charge something with it, but until you put it in some kind of uniform, where you have an electron, 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 and you can push them, then you do not have electromagnetism. And unless there's uniformity, electromagnetism can't exist. Once this singularity creates a photosphere and beta decay occurs and electrons form, or decay, and they're there already, they just come out of nowhere basically from a neutron. You know, they go through beta decay. You know, it's just physics. Alright, so whenever they decay and they come out or form and this photosphere forms, now they can start tangling. Okay? There's the electrostatic field starts to dim and electromagnetic field starts to come onto play. Because you're getting an alignment of electrons now. I mean, of course, they're all twisted and tangled, but you're actually getting lines, even if they're twisted, you're still getting uniformity. Okay, you see what I'm saying? You got uniformity. If you do not have any kind of body, then it's only electrostatic. You see what I'm saying? So electromagnetism is not a fundamental force. It's a fundamental product of the first three forces. The strong, weak, and gravity. You have to have those three into play before you can have electromagnetism. Because when you're spinning, say you're spinning this, alright? When you spin it and you start adding your electrons to the nuclear core here, and you start adding it, you got your centripetal force, alright? This spinning here, and all these electrons, you're going to start getting entanglement. You're going to get a fusion, and then you're going to start getting a magnetic field. You see what I'm saying? And then, once you have this magnetic field as your product, you start sweeping it off with, say, thermoelectric generators. You know, using thermodynamics. Ironically, this is what thermoelectric generators do. They like Peltier cells. Like Stonehenge, ironically. But I'm just saying, you use the thermoelectric generators or superconductors to sweep off that energy. So now you have this energy. They keep putting electromagnetism, like I was saying with this tokamak, they keep putting electromagnetism in it. This is why they're having a problem with their electromagnetism, because they keep thinking they need to put more in because they can't get it to do what they're wanting it to do. but they're not unified in their field. I'm just throwing it out there. But it's fundamental. You have to understand the nature of hot and cold rather than numbers. Because pre-singularity, technically, we didn't have numbers. You see what I'm saying? The universe forms numbers when it's born. You know, whenever it's literally born, it, over time, through evolution, cosmic evolution, numbers are created through decay. I mean, it's just the reversion of the universe creates all the numbers that we know. Fundamental relativity that we can actually observe, you know? So once we understand it's more fundamental than digital, because digital way, look, I understand it's helped us come a long way, but we're still missing something. We're missing this. We're missing the philosophical aspect behind it, the nature of hot and cold. Now, we do have the laws of thermodynamics, but we don't apply them like we should. The laws of thermodynamics apply to the universe more because it's the simple nature of hot and cold. It's solid facts from hot to cold. Look, the universe literally does this. See, it starts from a cold nuclear state. Okay, it goes through its alpha. All right, hot, quark gluon plasma, hot nuclear state. Okay, then it starts cooling. It's still hot, but it's cooler. It's going through its beta decay, so now it's a cooling, which is still hot, nuclear and electric. Okay, then when it dies, it's in a warm state. Now the universe is cold. It's like around 6 degrees above absolute zero, more or less. The universe is like, it has a temperature, a body temperature, like we do. Instead of 98.6, it's just like 6, degree, 5.9, something around there. Really cold. But that's its temperature, okay? Technically, matter is this nuclear and electric energy in a warm state, okay? That's all it is. It's like frozen energy, and that's what matter is. So now we're in a warm state, okay? Just like sparks flying off of a bottle rocket. Say a bottle rocket goes in the air and it blows up. You see it, all those sparks fly out, and then they start cooling and stuff, and then they just burn out. Okay, that's exactly what's going on. But it does it in waves over billions of years. But relative to space, it only happens in split second. You see what I'm saying? Because of how infinite space really is. You have to understand that all the Big Bang is a larger version of a supernova, or a very, very tiny version of a high-speed explosion. It just depends on how you're looking at the cosmos, because technically, like relative to space, it's tiny. But if you get on our scale, hell, our galaxy is probably this big compared to how big the Singularity really was. It wasn't a tiny dot. It depends on how you're looking at it, the relative scale. That's why we have Planck times. Billions and billions and billions and billions of second. Yeah, it's billions and billions and billions of a second. If you're space, you see what I'm saying? If you're space and you measure an explosion that's, just a split second because you're so infinite, then yeah, of course it's going to be billions of a second. You see what I'm saying? We're adding all these numbers to something, to an easy concept. We're overthinking it, with numbers. But we could understand it in a more fundamental way if we just apply our low and high-speed photography and size relevance. And understand the fact that size and time in the vastness of infinite space is irrelevant anyway. You see what I'm saying? So I'm just trying to help people understand something, because it's hard to understand the way scientists put it. It's like I don't even think they understand it themselves, And I can see it in a fundamental way, and I just want to help people understand it, because it's not as hard as we make it. See, here's a transitional state at some point. See, quarks, point particles are the only thing in the universe that are self-born. Nothing in the universe is self-born but quarks. You see what I'm saying? The only thing in the universe that is self-born is a quark, a point particle. And that's proven fact. And I committed that to mine because that's a very important factor. If nothing is self-born except for a quark, that means this has to be the beginning. And quarks are alpha. That's nuclear energy. And alpha, the beginning, and it means father. And we get nuclear energy from our father. So it's more fundamental than we're really realizing in some of these religions too, I know they hide things and lie and all that stuff just like governments do. They obscure the facts, And that's why I'm trying to help people see through, Lies everywhere. And I'm not trying to say, this is true 100%. I'm just saying I'm pretty sure, in my opinion, that this is correct. Okay? You don't have to believe it. Nobody has to believe it. I'm just trying to help people understand something that, is kind of hard to understand the way scientists lay it out. So I'm just, trying to help. So this is going to inflate, literally. The singularity is going to inflate. And that's when it's going through its beta. Because now particles, instead of being a dense neutron, just a solid quark gluon plasma, neutron, more or less, some dense, hot fluid, it's starting to cool. And it inflates, no different than a star would. But instead of creating other elements, as a star would do, this is actually creating the constituents for atoms instead, because it's pre-atomic. And then eventually it grows into a living universe. It's another phase transition. That's all this is phase transition. I call it zeta mechanics, because the closest thing we have is zeta potential. But I call it zeta mechanics because it's, the power of 6 and 7, more or less, because zeta is technically 6 and 7.